Today, Eric and I are going to be talking about grid-based computing and how it can improve process management. There are many benefits to using grid-based computing. The system is designed to boost productivity, maximize resource utilization, and simplify access to computing resources. A grid engine is what sits in front of a group of computers and submits the jobs to the various servers.
Imagine that you're at a grocery store, you get all the items you want, you go to check out. You have to choose between many different lines. Some with many customers, some with few customers, some that take cash only, and some that take credit only, and some where you can only have a certain amount of items to check out in that line. It's difficult to choose a line that will get you through effectively in a timely manner. It's the same with regular user computing. Grid engine computing allows the user to submit jobs to a server, and the server will decide what resources are available and send the job to the appropriate server depending on requirements.
In this scenario, the users don't know if the computer they are waiting for has the resources available that they need or not. So each user is taking a guess that the computer they are waiting for has the resources available. As you can see, this can cause a person to wait a very long time for the resources, and then to find out that the computer they should have been on was computer B or C. This scenario is set up like a multi-channel, single-phase line structure. But since each computer has specific software, it really doesn't work and can be very inefficient. This leaves the user to decide which computer would be most useful in their situation and can lead to long wait times. This can also lead to resources not being utilized to their fullest. The user could be waiting for a computer when a free computer is sitting right next to it and has the resources that the user needs.
With regular job processing, the users submit jobs to the resources manually. The resources that they submit to may not have the capabilities to get the job done most effectively. When too many jobs line up at one resource, they create an overload at the server. This queues jobs on overloaded resources that could be completed on other open resources. The solution to this problem is the grid engine system. This system, unlike the grocery store line, works more like a Taco Bell line. Customers stand in line with their order in mind. They wait until the next cashier comes available to take their order and complete the transaction. This method makes the line move faster and the resources are used more effectively.
Here we have a person that directs the individual users to the machine that best fits their needs. Since the person doing the direction knows what resources are available at each of the machines, she can make the best decision on where to send the user. This creates a more efficient system and allows near 100% utilization of all resources. Also, with this type of system, you're able to see which systems are being overutilized and creating a backup queue. With this information, you will be able to make better purchasing decisions on when and what to buy for additional resources.
The users submit a job to the grid engine. It then places the jobs with the best resource for the job that is needed. The grid engine has criteria that it uses to determine which job goes to which resource based on suitability, priority, and availability. This creates a high utilization of resources and gets the user's jobs completed most effectively. I'm probably going to want to do that again. Overall, a grid engine is a great tool to speed up computational jobs being submitted to the servers. Without a grid engine, the system is very confusing for the end user and leads to unwanted wait time. By placing the queuing server in front of the jobs, you can keep resource utilization at 80 to 90%.
A grid engine fits nicely with process management because it allows a company to script the process flow of jobs. It allows for the most efficient flow. Overall, the system will need to be tweaked for issues that occur or weaknesses that are found in the system.